Greetings and welcome to Dunneslab. Today's lesson is on dilutions. A common procedure encountered when working with solutions in the laboratory is that of diluting a solution of known concentration to a lower concentration. Dilution is the process in which more solvent is added to a specific volume of solution to lower its concentration. The same amount of solute is present, but it is now distributed in a larger amount of solvent. This is the original solvent plus the added solvent. It is important to note that the number of moles always stays the same. A very simple mathematical relationship exists between the volumes and molarities of the diluted and the stock solutions. The initial concentration times the initial volume equals the final concentration times the final volume. It is usually written M1 times V1 equals M2 times V2. In this equation, M1 and V1 are the molarity and the volume of the stock solution, the solution to be diluted, and M2 and V2, the molarity and volume of the solution resulting from the dilution. Because volume appears on both sides of the equation, any volume unit, not just liters, may be used as long as it is the same on both sides of the equation. Six molar hydrochloric acid is typically found in chemistry stockrooms. Our question is, how many milliliters of a 6.00 molar HCl stock solution are required to make 500.0 milliliters of a 1.50 molar HCl solution? It is usually best to write down information about the problem, such as what you are looking for, any formulas you may need, and information about what we are given. Our first concentration is 6.00 molar HCl, but we are asked how many milliliters of that solution are required, so we don't know the first volume. The final concentration is 1.50 molar, and the final volume is 500 milliliters. We can now plug our values into the equation. In order to solve for the value of our first solution, we must divide each side by 6.00 molar. This allows for units of molar to cancel out, and we are left with the value of our 6.00 molar solution required to be equal to 1.50 times 500.0 divided by 6.00. And because our units of molar cancel out, we are left with units of milliliters. So the value of 6.00 molar HCl required in this problem is 125 milliliters. Here is another problem. If 0.500 liters of a 1.00 molar H2SO4, which is sulfuric acid, stock solution are diluted to a final volume of 2.00 liters, what is the final concentration and how do you mix this solution? Again, we need to write down what we are looking for and any formulas that we need. Next, we will write down the information we are given. In this problem, the final concentration is unknown. We can now plug these values into our equation. In order to solve for our final concentration, M2, we need to divide each side by 2.00 liters. This allows units of liters to cancel out, and we are left with the final concentration in molar to be equal to 1.00 times 0.500 divided by 2. Because our units of volume cancel out, we are left with units of molar. So the final concentration is 0.250 molar. And now for the second part of our problem. How would you mix this solution? As we all know, 6 molar sulfuric acid can be highly reactive, and therefore it is not recommended to dilute it by simply adding water to it. By adding water to sulfuric acid, an exothermic reaction will take place, and it may cause harm to the experimenter. In order to dilute any acid, always add acid to water, as water is a good absorber of heat and will absorb heat from the exothermic reaction. Step 1. Put on goggles, rubber gloves, tie back long hair, and put an apron on. Step 2. Calculate the required amount of water to be added. V2, our final volume, is 2.00 liters. Subtract out the stock solution, which is 0.500 liters. This leaves 1.50 liters of distilled water to be added. Add 2/3 of the required amount of distilled water to the glassware. Step 3. Slowly add the acid to the water. Never add water to concentrated acids. The acid may splatter and generate acidic steam. Slowly stir to mix the solution. Step number 4. Once the solution has cooled, dilute the solution to the proper volume with distilled water.